So today at this Edge AI workshop, I'm going to share with you an open source library from Hugging Face, which is called Optimum. And I am a machine learning engineer at the optimization team of Hugging Face, and our team works on the AI infrastructure work of Hugging Face. And we also collaborate a lot with different open source communities and also our hardware providers in order to accelerate model training and inference, of course, different backends, different hardwares. And I am one of the core maintainer of Optimum library. When I started with Hugging Face, I started by integrating ONNX and ONNX runtime into our ecosystem. And right now, I mostly work with Amazon, AWS Neuron AI accelerator to ensure that our model could run smoothly on their Trainium and inferential instances on EC2. So now let's jump into Optimum finally. So what is Optimum? I think many of you might be familiar with Hugging Face Transformers library, which is our most widely used library. And actually, Optimum is a library built on top of Transformers and some other key libraries that we have here at Hugging Face, including diffusers for diffusion model, accelerate for different distributed setup for both training and inference. We also integrate with PAT for those methods like LoRa, the low rank adaptation, etc. And all of these libraries that you might be more familiar with actually make those state-of-the-art models and techniques accessible to different users and audience. But the role of Optimum is slightly different. Our goal is more to make those short-term machine learning models production ready by abstracting away the complexity on migrating to different hardware platform, especially those newly emerging ones. And to achieve this goal, as you might know, here at Hugging Face, our goal is to democratize good machine learning through open collaboration. And for Optimum, we are doing the same thing. So we are collaborating closely with our hardware vendor. For example, like NVIDIA, we also collaborate with AMD. We collaborate with AWS on their Neuron AI accelerator. It's a project that I'm currently working on. And we also collaborate with Intel, both on their CPUs and their Gaudi AI accelerator that they call HPU, the Habana Processing Unit. We also work with Google on their TPU. We work with Furiosa AI. Maybe it's less known. It's actually a hardware startup from Korea. Except for all those hardware vendors, we also collaborate with some teams that maintain open source frameworks. For example, we collaborate with ONNX runtime that is maintained by Microsoft. We recently started our collaboration with Execute Torch. It's a framework dedicated to Edge AI, maintained by a team in Meta. So today's workshop is about Edge AI. So I would like to talk about some Optimum sub-packages that are most relevant to Edge AI. And the first one should be ONNX runtime. I will start by what is ONNX runtime. So ONNX runtime actually stands for Open Neural Network Exchange. It's an open standard format for representing machine learning models using protobuf. And when it was created back in 2017, some sort of prehistoric age for AI, the idea was very ambitious. We wanted to create a unified and hardware agnostic format that could be deployed on any hardware, as you can see in this graph. everything goes into ONNX, and ONNX could be deployed into any hardware. But the cruel reality is that the pace of model innovation has often outstripped the pace of the updates in ONNX. So when you want to convert a new model into ONNX format, you might find, for example, some operators are not yet supported by ONNX, and you might then need to implement a custom op, which could be quite painful. And if like multiple vendors need to implement their own custom op, it could be quite redundant as well. So as a result, by the end of the day, actually every hardware vendors, they usually just build their own format that is strongly coupled with their own software stacks. For example, we have NVIDIA TensorRT, they have TensorRT engine. For Apple's Core ML, they have their ML model. And for the project I'm working on, the Neuron, actually they have also their own format called NEF. But despite all this, actually ONNX is still widely used as a common exchange format support by many frameworks, tools, and hardware, especially for edge AI deployment, which is nice. And we just talked about ONNX. So what does optimal ONNX look like? Actually, optimal ONNX is composed of two main parts. The first part is that Optimum provides an exporter to convert PyTorch model available on Hugging Face Hub into ONNX format. And to make this process easier, in Optimum team, we have standardized a set of tools like dummy input generator, like ONNX config class to set up everything that is mandatory for tracing a model. And we also create a click commands, as you can see in this snippet. By using the Optimum CLI, you can easily just specify the model ID on Hugging Face Hub or its local path to export the model from PyTorch into ONNX format. And on the second part, you are also very welcome to join our ONNX community. It's an organization on Hugging Face Hub where you can find two very useful spaces. Spaces is the application demo that we host on Hugging Face Hub. And the first one is Convert to ONNX. With this app, you can easily convert your model on the fly from PyTorch to ONNX format. And the second spaces is called ONNX Model Explorer, which could help you to browse existing ONNX model, so you can use it directly. And the second part of Optimal ONNX is actually ONNX runtime, what we call ORT. ORT is a cross-platform engine for both training and inference on ONNX model across a vast variety of hardware backends, both in cloud and for edge settings. So once a model is converted into ONNX format, you can load and run it with optimal ONNX runtime. As you can see in this snippet, actually those maybe you have already found like those APIs are actually all APIs in Optimum are intentionally designed to look very similar to what we have already in Transformers library. And the idea is that we want the user feel effortless when they transfer from Transformers to Optimum or moving across different sub-packages of Optimum. Like here, for example, you can see there's an API called ORT model for causal LLM. Actually, is the equivalent in Optimum as the auto model for causal LLM in Transformers, if you are already familiar with Transformers. And once the model is loaded, you can also use directly the pipeline API in Transformers to run text generation. simple inference, ONNX runtime also offer a tool, a huge set of features to optimize the inference. For example, in Optimum ONNX runtime, we also support graph optimization on multiple levels. You can either remove redundant nodes, like the very classic constant folding, constant elimination. You can also fuse a lot of compute-intensive operators. You can optimize the layout for better performance as well. And we also built a ORT quantizer so that users can also apply quantization to run models under lower bits. And here I would like to introduce you a concrete example, which is called Transformers.js. I'm very sorry, actually it's misspelled. It's Transformers.js, not Transformer.js. It's actually a project designed and created by a very talented co-worker in Hugging Face. His name is Joshua Lochner. Actually, Transformers.js is a JavaScript library that could run machine learning models directly in the browser, which means it's serverless and is cost-free if you use your own compute for either CPU, GPU, or NPU. And in this project, Transformers.js, actually Joshua uses Optimum to convert models from Hugging Face Hub to ONNX format, and then he ran it directly with ONNX runtime into the browser. And that's for Optimum ONNX. And now we will talk a bit about a new subpackage that we recently just added to Optimum. In this project, we actually collaborate with Meta's Execute Torch team to add their Execute Torch framework. So when they introduced Execute Torch for us, they said, oh, we have like PyTorch, ONNX runtime is quite a headache, and we just want everything to stay in PyTorch ecosystem, right? And that's why here comes the Execute Torch, which is a very ideal solution for deploy PyTorch models on edge devices. It actually optimizes the model for specific hardware during the export and lowering process. And they also customize quite a bit the memory planning, which is very crucial for edge devices. So as a result, it's quite vastly improve the performance for on-device deployment, and it's a project that currently the Optimum team invests quite a lot on. And for Optimum Execute Torch, actually so far we have quite a wide range of backends that are supported. For example, we have Core ML on iOS, we have XNM Pack for Android, and for Optimum Execute Torch, actually the mechanism is just like every other subpackage for Optimum. We introduce a very easy way to convert the model from Hugging Face into a specific format. Here is the Execute Torch program. And then we optimize the inference by specifying the different hardware. You also have a very seamless integration with Hugging Face Transformer, but not only, it also integrates very well with other packages like diffusers, etc. of Hugging Face, and also the Hugging Face Hub, which is the core of the whole Hugging Face ecosystem. And here is a small example of using Optimum Execute Torch. As you can see in the snippet, once again, we have an API that is really similar to the auto model of transformers, which is called Execute Torch model for causal LLM, similar to auto model for causal LLM in transformers. And we can load the checkpoint from Hugging Face Hub directly. We can specify the backend we want to use. For example, here is XNN pack if we want to deploy on a mobile phone. We can activate those specific attention implementation to boost the inference performance. For example, here we have a custom scale dot product attention for CPU based on flash attention. We can also enable a custom KV cache that use custom op for efficient in-place cache, which can also boost the performance. You can also apply quantization in Optimum Execute Torch. We support post-training quantization for both linear layers and embeddings by leveraging the Torch AO library of PyTorch ecosystem. And once the model is exported, you can run inference just like what we do, the same way as what we do with transformers. And here is a benchmark result conducted by the PyTorch team. They made a benchmark with some of the most popular models in Hugging Face Hub by testing with different backend and hardware. And you can also find more variety of models, benchmark result directly on the page of PyTorch. And except for those two sub-package of Optimum I just talked about, we also have two other sub-package of Optimum that is a little bit related to the topic of Edge AI workshop. So we have Optimum A and D sub-package, among which we support AMD GPU, and we also support AMD Ryzen AI NPU. And the mechanism is quite the same. If you look into the documentation of Optimum A and D, what you usually will find is that you have some sort of APIs that are really similar to what we have in transformers. You can convert really easily a PyTorch model to a supported format and run inference with those APIs that you might be already familiar with to run inference. And we also collaborate quite a lot with Intel, for example. I think there are quite some folks from Intel today. We have a very friendly collaboration with Intel, in which we have the Optima Intel sub-package, in which we integrate some tools developed by Intel. For example, we have the Intel Neuron compressor. We also support OpenVINO, and we also integrate IPAX, which is an extension for PyTorch from Intel. And last but not least, Optimum is an open source library. Although we collaborate with a lot of hardware vendors, it's just like every other open source library from Hugging Face. Its growth is always driven by the contribution from the community. So for each sub-package, actually, the first thing we have for documentation is to set up a page for guiding users to contribute to this sub-package. We have always some sort of tutorial with step-by-step guide telling you how you can add new features and new models into those sub-packages. And so you are very welcome to contribute to us. And please, if you are interested in the Optimum project, feel free to file pull request to us, ping me or other team member for review. And you are also, if you don't want to submit pull request, you are also very welcome to just open an issue telling us what you want us to support for different, for example, hardware for different models. And we are more than happy to collaborate and help out. And thank you. That's all I want to say, talk about Optimum. Yeah.